Hi, this is Mr. Cardoso, and here we have a little video lesson on polynomials. So, polynomial is a simplified algebraic expression. For example, 2x squared plus 3y minus 5z, where there are no like terms. Each term is separated by a plus or minus sign. So you can see the plus or minus sign here, and we have three terms. This is all one term, this is all one term here, and then this is all one term here. So we have 2x squared is one term, 3y is another term, and 5z minus 5z or negative 5z is another term. The coefficients are the whole numbers, and the variables are the letters or symbols that represent unknown numbers. So, or variables. So you can see in red here we have the coefficients. Okay, color-coded red coefficients, and in blue we have the variables, okay, that represent unknown numbers. So some polynomials have special names. While they are all polynomials when they have multiple terms, some polynomials have special names as well. So we have a monomial, which contains only a single term. A binomial contains only two terms, and trinomials contain exactly three terms. So here's an example. Let's classify each of the following polynomials according to the type. So this one here, 3x squared, there's only one term, so that would be a monomial. 2x plus 3, there's two terms here separated by a plus sign, so that would be a binomial. 2x, there's only one term there, there's no plus or minus sign afterwards separating, so that's a monomial. Put a little bit higher there. 2x squared minus 3x plus 2. Okay, there's three terms, 1, 2, 3, so that would be a trinomial. Okay, here, two terms, so that's a binomial. And here we can see there's three terms, so that's a trinomial. Okay, moving along. Okay, then we have the degree of a monomial is the sum of the exponents of its variables. So we have to look at all of the variables in the term and then sum the exponents. So here we have degree of 3 in this one because this exponent here on the x is a 3. Here on the x we have an exponent of 1, and on the y we have an exponent of 1, so the total degree then is 2. We have to sum that or add them. Here we have a 2 on the A, a 3 on the B, and if there's nothing written here, there's a 1 on the C. So 2 plus 3 is 5. So we have 2 plus 3 plus 1, which equals 6. So the overall degree is 6. Okay. Now, we can also have a degree of a polynomial, which is the greatest sum of the exponents in any one term. So here we know that the degree of this term is 2. The degree of this term is only 1. So the degree of the entire polynomial would be 2. Here the degree is 7, 3 plus 4. Here the degree is 4, 3 plus 1. And here the degree is 2, 1 plus 1. So the overall would be 7. That's the largest one, the greatest sum. Okay, and here we have 5, here we have 5, and here we have actually 6, 5 plus 1. Okay, so the degree of this one would be 6. Okay. Collecting like terms. So like terms, a polynomial is made up of terms. To simplify a polynomial, we want to collect all the like terms to make it easier to work with. Terms are considered like if they contain the same letters with the same exponents on those letters. Okay, the coefficients don't have to be the same. So let's look at some examples here. This is a like, these are like terms because we have an x here and an x here, the 3 and the 3, the exponents are the same. Even though the coefficients are not the same, that doesn't matter. They are still considered to be like terms because the variables and the exponents are the same. Here, like terms as well, we have an xy and an xy, and of course here they're like terms as well. Even though these two are not written in the same order, we know that we can rearrange them because For example, 2 times 3 is equal to 3 times 2. They're both equal to 6. So if I take this a squared and put it over here and this b over here, you get the same thing, and then you have the same exponent. So the important thing is to have an a squared there and an a squared there. You have a b here and a b here. So therefore they are like terms. Over here they're unlike. Well, why? In this case, it's unlike because we have different exponents. Here we have a 3, and here is a 1. So the exponents are different, even though the x's are the same. This one is because we have different letters. Okay, it's xw, and this is xz. So the z and the w are not the same, so these are unlike terms. And here we have different letters altogether. Here we have a squared b. In this one, there's no b. In this term and this term are actually separate terms. Okay, this term and this term are separate terms. So in this term, there's no b, and here we have a b. So that's why these two are unlike. In here, we have a b, but we don't have an a squared. We need an a squared in here to compare it to this one. So that's why all three of these are unlike terms. Okay, I'll just do one of these examples, and I'll let you try the rest on your own. We're collecting like terms here. So let's underline what's like. We have 2x and 5x that are the same. Is there any more? This is a y. That's an xy. Not the same, not the same, not the same. So this is a positive 2x, and a positive 5x gives us a 7x. Okay, so we can cross those ones out as being done. Let's change the color here. Now let's see, 3y, positive 3y, any more y's? Yes. Negative 2y. So positive 3 minus 2 can be combined to be 3 minus 2 gives us plus 1y. Now the 1, we don't actually have to write it. We can just say plus y. Okay, and let's change the color here for the next one. We have xy minus 4xy's and plus 6xy's. So we have minus 4 plus 6, okay, or negative 4 plus 6, which gives us positive 2xy. Okay, so those are been combined, and that's as far as we can go in terms of simplification. Like I said, this 1 doesn't have to be written, so we can do another line where we don't write the 1, but that's pretty much it. Okay, I hope you enjoyed this video lesson.